Let's talk about an interesting integral, just the integral of sine, fairly simple, from 0 to infinity. Here's a good old sine wave. What would you say that integral is? Think about it graphically. We could say I'm adding up area as I move along here, so I'm going to start by adding area not very quickly. By the time I get here, I'm going to be adding area very quickly, and then by the time I get here, I'm adding area less quickly and even adding negative area. So I'm going to be doing that. So this will be capital F of x. Go ahead and take the antiderivative. So we get antiderivative of sine is negative cosine, right? From 0 to infinity. Or better would be to say what's the limit as b goes to infinity, negative cosine of x from 0 to b. We'll move the minus out there. Say the limit as b goes to infinity, cosine of b minus cosine of 0. So what do we get? So we get a minus, and then we'll bring this part in. Limit as b goes to infinity, cosine of b minus cosine of 0. So what is the limit as b goes to infinity of cosine of b? Well, we can draw cosine. Easy enough. Dot, dot, dot. As b goes to infinity, what do the y values do? Do they approach a single destination? Well, they keep approaching 0, but then they dive below 0 all the way to -1, and then they come back up through 0, up toward +1, and then they come back toward 0, but then dive through and go to -1. So this limit does not exist. We can't say that it's 1. We can't say that the limit equals 1. We can't say that the limit equals -1. We can't say that the limit equals 0. We can't say that the limit equals plus or minus 1. Some people try that. The limit just does not exist. The function oscillates without settling down. So the limit just does not exist. So what does that mean about this integral 0 to infinity sine x dx? That just does not exist, or we could say it's a divergent integral. It's not divergent to infinity. It's always between 0 and 2, for example. It's the oscillating without settling down kind of divergent. Right, so hopefully that clears up a misconception about what divergent integrals look like. They don't always zoom off to infinity. Sometimes they just wiggle without settling down. It might be a little disappointing that the integral of sine x all the way to infinity just gives a divergent integral, but that's what it is.